AP Physics 1 Workbook, Unit 4, Work in Energy. Activity K, Energies in Systems. Please remember to read along with me, pause and rewind the video as necessary. Let's begin. In this scenario, consider a car that is initially moving on a straight roadway. The road may be going uphill, a downhill, or on a flat road. The driver of the car may be pressing the gas pedal, the brake pedal, or no pedal. Only energy transformation that can take place are chemical energy becoming mechanical energy, that is when the gas pedal is pressed, and mechanical energy becoming thermal energy when the brake pedal is pressed. Chemical energy levels may be thought of as levels of the gas gauge. Well, that might be helpful later on, we'll see. For each situation, fill in the sentence explaining how the system's mechanical energy is changing. Create an energy bar chart that represents the energy transformations and use the blank spaces to explain how you formulated the answers. Part A. A car is traveling downhill while the driver presses the gas pedal. Well, normally you are going to start with gravitational potential energy. So let me start there. Let's see. 1, 2, 3, 4, 5. Okay, I'll go ahead and what I'm going to do is I'm going to start with essentially, just to kind of make this sort of easy to work with, I'm going to sort of use just kind of an arbitrary 20 units. That's where that way you kind of know what numbers I'm working with here, okay? So my total energy between all the energies is going to be 20 units, okay? Now, do keep in mind, total energy is conserved. Although mechanical energy may be lost every once in a while to thermal energy is still part of total energy, okay? So I'm kind of working with a total of 20 units so you can see how the bar charts sort of balance out. Well, if I'm starting at the top of a big hill, I'm going downhill, obviously, according to this, and pressing the gas pedal. So the driver is going downhill and pressing the gas pedal. If you're going downhill, you're starting with gravitational potential energy. Okay, so I'm going to start off with that amount right there. 1, 2, 3, 4, 5, 6, 7. So I'm going to start off 7 units of gravitational potential energy. Again, I'm kind of coming up with an arbitrary value here, so don't read into it too much why I'm choosing the number 7. But here's one of the points I do want to make out. If I'm talking about 20 total units that I'm going to arbitrarily be working with here to show you these bar charts, I'm starting with 7 units of gravitational potential energy. Well, if I'm speeding up because I'm pressing the gas pedal, that means I also have gas in the tank, which means I have a remaining 13 units of chemical potential energy, which will be about up to here, roughly. Okay, and so you can see the two energies right now total up to 20 units of total energy, okay? But now, as you're going downhill, what's going to happen is your gravitational potential energy will decrease to 0 and it will become kinetic energy. However, you're pressing the gas, which means you're going to increase the overall mechanical energy because some of it came from chemical energy. So the mechanical energy of the car is definitely increasing, right? And while the mechanical energy of the car-Earth system is also increasing. Okay, so again, let's make some sense of this. If we're going downhill, but we're speeding up, okay, normally as you go downhill, your potential energy goes down, your kinetic energy goes up, and your total energy remains constant. Your mechanical energy stays constant, right? But if you're pressing the gas pedal as you do this, you're injecting more mechanical energy into the system. So although you might be decreasing potential energy, you're increasing more kinetic energy than you are decreasing because of the pressing of the gas pedal because of the conversion of chemical energy into kinetic energy. So what I'm going to do is I'm now going to raise the kinetic energy higher than this amount here because some of that came from the chemical energy of the pressing the gas pedal. So I started with 7 units of potential energy. I'll go ahead and raise that to about, I guess, 11 units maybe? Yeah. Okay, so I'm raising that to about 11 units of kinetic energy. What that's showing you is some of that kinetic energy was the original 7 units of gravitational potential energy, plus some of the chemical energy that I injected into it by pressing the gas pedal, which means now the chemical energy has to come down. Well, if I just went from 7 to 11, I added 4 units. You can see I added 4 units of additional energy from my gravitational to my kinetic. So I added 7 additional units, right, of mechanical energy, 4 additional units, excuse me. So I have to take 4 units away from my chemical energy. So if I had 13, you can see I'm down to what, 9 now? But you can see the total energy is still totaling up to 20 units. Okay, so explain how you formulated your answers. Let's go ahead and take a look at this. Assuming the driver presses the gas during travel, we would see the potential energy transform into kinetic energy while the gas tank level would decrease. So since the gas tank level is decreasing, the chemical energy is decreasing. While the ride occurred, chemical energy would transform into kinetic energy, leaving more kinetic energy at the end than potential energy you had at the start. Part B. The car is traveling uphill while the driver presses neither pedal. Okay, so think about it. What's the car doing? It's coasting going uphill. That means the car has to be, slowing going forward. All right, so that means what happens? If the car is slowing going forward, that means the mechanical energy must be, and I'm saying the mechanical energy only of the car, relating to the kinetic energy of the car. You're slowing down, right? Therefore, mechanical energy of the car only is decreasing. Now, the mechanical energy of the car Earth system, well, that's remaining constant because A, I'm not pressing the gas pedal to inject more energy, I'm not increasing more mechanical energy than I already had, and I'm not pressing the brake, which means I'm not decreasing. So if you think about it, pressing the gas pedal would increase mechanical energy. Pressing the brake pedal would decrease mechanical energy. Pressing neither pedal basically causes what? Kinetic energy to convert into gravitational potential energy, keeping the total energy constant. Right? And how do we draw that? Very simple. I'm going to start with same thing I had before. In fact, I'm going to start with the exact same thing I had before. However, I don't start with gravitational potential energy because I'm starting at the bottom of the hill. That would be kinetic energy. So my initial bar chart would look something like this. Okay, I've got gas in the tank, okay, but I don't press pedal. Okay, the kinetic energy I have at the bottom of the hill simply would become potential energy at the top of the hill. Straight conversion from this to this. And my total mechanical energy remains the same. In other words, kinetic right into potential. Okay, and notice my total energy overall stays at about 20 units. Explain how you formulated your answer. Since the driver is pushing neither pedal, the chemical energy and thermal energy would remain the same from the bottom of the hill to the top of the hill. The transformation here is kinetic energy of the car in gravitational energy or gravitational potential energy of the car Earth system, and that would remain constant. Part C. The mechanical energy of the car is constant, and the mechanical energy of the car Earth system is decreasing. Okay, well, the energy relating to the car being constant means the kinetic energy and the speed are constant. I'm just writing notes to myself to help this make sense. Okay, and it says only the car Earth system is decreasing. So if the car Earth system is decreasing, right, but my speed is remaining the same, then a couple things could be happening here. One, I'm going downhill. Actually, only one thing possible. I'm going downhill, right, to have the car Earth system decrease mechanical energy, because the car Earth system is relating to gravitational potential energy, and the mechanical energy of the car remaining constant is telling you that the kinetic energy of the car is remaining constant. Now, how do you keep the speed of the car remaining constant as you're going downhill? Because if you're going downhill, you should be accelerating. You should be going faster. So how do you prevent yourself from going faster? You have to be pressing the brake pedal, which means I'm going to start with my 20 units of energy, okay? But here's kind of the way this one's going to look a little bit different, okay? I'm actually going to be, let me see here. Actually, I'm going to go ahead and change this up just a bit. Since you're moving, you're going to have kinetic energy. Since we have height, we're going to have potential energy at the beginning, okay? And I'll start with about, let me see, 1, 2, 3, 4, 5, 6, 7 units of 1, 2, 3, 4, 5, 6, about 7 units of potential energy. And kinetic energy. So basically I'm going downhill, right? But my kinetic and potential energy, and I'm arbitrarily, again, why am I doing this right here? I'm arbitrarily making them the same value. Again, because what I'm trying to do is I'm trying to set up a scenario from the beginning to the end. It's not really important that, well, hey, why are they both the same? That's not really important. It's an arbitrary setup, okay? But what we're going to do is we're going to take that information and use it as a comparison in the beginning of the scenario to the end of the scenario. That's where it's important, is the energy conversions. But now, if you can see, if I have 7 and 7, that would be 14. I think I might have too much chemical energy because I want to keep it at, let's see, 14, 15, 16, 17, 18, 19, 20. Okay, so no, it still works. Let me see, I have... Okay, let's see. So it's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 27. Okay, so my mistake. I'm not using 20 units of energy. It's more like 27. I think I just counted the additional energy rather than the total energy from the bottom. But anyway, I'm working with 27 units of energy, not 20. And so I'm going to see how all that energy kind of balances out. Well, one thing, if I'm going downhill, right, I'm not pressing the gas pedal, then my fuel gauge should stay the same and my chemical energy should not change. So that's going to remain at about 13 units, okay? If my kinetic energy is staying the same because it's keeping the same speed, then my kinetic energy should remain the same amount. Okay, but my potential energy's gone down significantly as I go downhill. Okay, and what's going to happen is that is going to convert itself into thermal energy because the brake pedal itself, the friction, the work done by friction on the brake pedal is converting itself into the heat and the thermal energy of the surrounding air. And so that thermal energy is going to go up. Well, now, if the chemical energy did not go down and the kinetic energy did not go down, that means the decrease in potential energy contributes to the increase in thermal energy. So what I'm going to do is I'm going to drop the kinetic energy. Normally the potential energy is up to about, 7 units. So I'm going to drop it down to, let's say, 2 units, something like that. But that means that dropped to 2 units, then I would have, let me see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That means this thermal energy would be up to 5 units? Something like that. But I should have the same total mechanical energy from beginning to end. Explain how you formulated your answers. To keep mechanical energy of the car constant means to keep the kinetic energy and thus the speed of the car constant. Okay, options possible would be either going uphill, pressing the gas, going downhill, pressing the brake, and flat with no pedals. If the car-earth system is losing energy, this cannot be from decreasing kinetic energy. We were told the kinetic energy stays constant, so that can't be it. The potential energy is decreasing, and so we have to be going downhill, and the only possibility there would be downhill pressing the brake. Okay, finally, part D. The mechanical energy of the car, of only the car, is decreasing, and the mechanical energy of the car-earth system is increasing. So let's break down what's happening here. We are told the mechanical energy of only the car is decreasing. So that means kinetic energy, let me see. Kinetic energy is decreasing. Mechanical energy of the car-earth system is increasing. Okay, so what are possibilities? Uphill, downhill, or flat? Okay, so for the kinetic energy to be decreasing while the mechanical energy of the car-earth system is increasing, well, right there, that should tell us that we're going uphill. Okay, but here's the thing. If you're going uphill and the mechanical energy of the car is increasing, the mechanical energy of the car alone is decreasing, and the mechanical energy of the car-earth system is increasing. So in order to make that happen, let me see. Well, you couldn't be pressing neither pedal, okay? If neither pedal were pressed, then the total energy of the car-earth system would remain constant, okay? And that's not happening, it's increasing. You can't be pressing the brake, because if you're pressing the brake, you'd be decreasing the mechanical energy of the car-earth system. It's increasing. So although the kinetic energy of the car is decreasing, that's because you're going uphill, the total energy, the total mechanical energy of the car-earth system is increasing because you're pressing the gas pedal as you're going uphill. So in other words, some of that chemical energy is going to be converted into the increase in potential energy to get you uphill, essentially. Not that you're going faster. You're not going faster. You're going slower. okay? But you're not going as slower as you would be if, let's say, the energy were constant. Okay, so what might that look like? Well, I'm going to go ahead and start with the same chemical potential energy that I have been, about 13 units or so. Let's see, 1, 2, 3, 4, 5, 6, 7, and we'll start with the same kinetic energy. Okay, but you're at the bottom of the hill, so we're starting with very, very little potential energy at the bottom of the hill. And I'll put that at about 2 units high, something like that. Okay, now what's happening here is there needs to be a drop in the kinetic energy because you're slowing down. So to do that, I'm going to drop the kinetic energy from about 7 units to about 4 units. So it's slowing down just a little bit. Okay, you still have kinetic energy because you're pressing the gas pedal, right? And because you're pressing the gas pedal, you're reducing the chemical energy. Let me see, I'll reduce that to about 5, 6. I'll reduce the chemical energy from about 13 to 8, so I'll reduce it by about 5 units, which means the gravitational energy has to increase by the same decreases in these other energies. So you decreased 5 units of this and about, 3 units of that? That means you have to increase your potential energy from 2 to 10, in 8 units? Is that right? Yeah. Okay, so again, what happened? The chemical energy here, while pressing the gas pedal, okay, and the kinetic energy that you have both contributed to an increase in 8 units of gravitational potential energy. Explain how you formulated your answers. Well, the car must be slowing if its mechanical energy is decreasing, meaning the kinetic energy has to be decreasing. The car must be going uphill if the car-Earth system is going to increase in energy because the increase cannot come from kinetic energy. So it's got to be coming from a rise in gravitational potential energy. The speed of the car will naturally decrease. Therefore, with no pedals, the kinetic energy would turn into potential energy. But we need more energy than that. So the car-Earth system energy can also increase and not just remain constant. That means we have to be pressing the gas pedal, but not to the point where we make the car go faster than it did at the bottom of the hill. So the car is still slowing down, but that pressing of the gas pedal and the conversion from chemical energy becomes an additional rise in gravitational potential energy.